Okay, some more problems from section 4.5, and this is another cosine. And again, we've got the whole shebang in here, and remember, you have to kind of look at these equations and be able to identify, if I look at this equation, what's the amplitude? That's -3. And what's the period? Well, I can't readily see that. And what's the shift? I can't really see that, so we have to kind of doctor this up a little bit. So let's work on this here. So we'll say y equals -3 cosine. Now I've got a 2 here, and I need just an x to get everything in the right form. So I have to get a 2, so I'll put a 2 in front so I can factor that out easier. So I'll put a 2 in front of the pi. So I'll multiply pi over 2 by 2 over 2, which is just 1. So it'll be 2 pi, and then over 4. 2 times 2 is 4. And then when I factor out that 2, y equals -3 cosine, and I've got a 2 in front. And what's left is x minus, if I take the 2 out, that's pi over 4. So just by doing this algebraic manipulation, I've got it set up. So now it's in a nice form. If I look at this, I can see the period is -3. I'm sorry. The amplitude is -3. Well, amplitude is up and down 3. I'm just going to start negative and go positive. So the amplitude, I could say, is 3, but beginning negative, or -3 if you so desire. The period is going to be determined by this. And remember, the period equals 2 pi over b. This is my b too, so my period is pi. That tells me my period is pi. And I know my subdivisions are just going to be the period divided by 4, so pi over 4 will be the length of each of my 4 subintervals. And what's the shift? The shift is to the right, pi over 4. So now when it's in this form, I can see the shift, I have a way of finding the period, and I can see the amplitude. Okay, so let's put our points in here. Now, again, this is the cosine, so it's going to start at 1. Okay, ideally or normally it starts at 1, but it's shifted pi over 4. So this is pi, this is 0, and I divided pi into 4 equal subintervals. So this is where I'm going to start. So I'm going to start at pi over 4 because of the horizontal shift. 2 pi over 4, 3 pi over 4, 4 pi over 4. So this goes to 5 pi over 4. It could be pi over 2 and 3 pi over 4. So 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And I'm going to start here and go to there because my period is pi and my shift is pi over 4. So that's where I'm going. Shift is pi over 4 and period is pi. Okay, so that's where I'm going. Okay, so on the cosine, I normally start at 1. But since this is a -3, I multiply that 1 by -3 and I get -3. So I start at -3. Then I go to 0, that's not going to change. And then I usually go to -1, so that's going to be now a +3. Back to 0, and back to my starting point. There's your cosine curve, flipped. Okay, that's what you got. Okay, so let's graph it. So it's going to go up like this. And actually changes concavity, is what we call an inflection point right there. Talk about that when you get to calculus. Comes back down around. That might be a little bit sharp. You might want to round this off a little bit. And then again, it comes down like this. Darken that in to round that off a little bit. There we go. So very close. Okay, so that's something like what you've got there. Okay, then you can see we have a period of pi, amplitude of 3, except it's negative, so it's flipped. Okay, and a shift to pi over 4, so it's flipped over. Or shifted over, shifted over, pi over 4. Okay, hope that helps. Okay, let's take a look at 53. Now these are just vertical shifts, so these are a little bit easier. And I think I told you when you have a vertical shift, all you do is just draw a kind of a new axis. This is going to be shifted up 2, so I'll just draw my new axis up 2, and I'm just going to graph the sine, but I'm going to pretend like that's the x-axis. That's my shift axis. Okay? And remember that the amplitude is just 1, So I can put my points in here, and remember the sign starts at 0, so it goes 0. And remember the period for the sign is 2 pi. So I should have put these subdivision points in. I don't know why I didn't do that. There we go. This would be pi over 2 and 3 pi over 2. And I just started 1. I go up 1, back down to 0, down to negative 1, and back up to 0, and that's the way we graph the sine curve relative to the x-axis, except we just shift everything up. So it could look like this. Now that's I don't normally make the one that narrow, but because I had a shift of 3, I had to kind of do that. Otherwise, I'd use up a whole half a sheet of paper. So something like this. And see, I'm going up 1, down 1, and 0. So those are my points there. Okay? So there you go. So there's your sine of x plus 2, just shifted up 1. Okay? Same period, 2 pi, so that didn't change. The period didn't change. The amplitude didn't change. Okay, number 55 is the same way, except my shift is negative 3, so I'll put my axis down negative 3, and then I'm going to draw it like that from there. Jeez. These are the same points here. Okay, so I have to put the subdivision points in there, so it goes down there. It goes down there also. There's my 2 pi. And I better put negative 4 down because I didn't do that. Bring my axis down just a little bit down there. There we go, okay? And then again, remember the cosine starts at 1. And this is going to be my starting point, so that 1 from here would be here, up 1. Then down to 0. Then down 1 here, then back to 0, and then back up 1 at 2 pi. And so there's our cosine, but shifted down 3. Let me kind of move my paper here so I can get my concavity making sense here, so I can draw a relatively accurate cosine curve. And like I said, that isn't normally, I usually use 2 of these if I have a regular amplitude, but because we're shifting, I want to show you relative to the axis. That's what we would have. Okay. So this is actually, don't foul this up. This is actually right here. This is the y equals the cosine of x minus 3. Okay. Okay. This is for this down here. I should maybe. Do something like that so you realize it's a different problem. Okay, so that was this one. Kind of went down here. So this is this one. This is actually my axis up here. Just looks a little skewed. And then the last one here, y equals, this is going to be a sine shift. This would be a vertical shift of 1. So I have a new axis here. And I've got a period of 2. And then I've got an amplitude of 2. An amplitude of 2, and what's my period going to be? Okay, my period, remember period equals 2 pi over b, so that's going to be 2 pi over 1/2, which is the same thing invert multiply as 2 pi times 2 over 1, which is 4 pi. So my period is 4 pi. Which is why I put all these in. This is 1 pi, 2 pi, 3 pi, 4 pi. So that's my period. This is my sine. My amplitude is 2. So let's go to town. No shift. Okay. Amplitude of 2. Period 4 pi. Vertical shift of 1. So I better put the 1 in. So here's the 1. Okay. We kind of use a different color here so this doesn't get confusing, to kind of block these off so you see what's going on here. So we can kind of separate these problems. go. Okay, so this was number 55. You can see it there. And then this is number 57. Okay, that helps a little bit. Anyway, so let's get this is going. This is where we're shifted up 1. This is the sine curve. So I'll start at 0. And normally, these are my 4 subdivisions. If I take 4 pi divided by 4, we'll get each subdivision. Remember, if you take the period and divide by 4, you get pi. That's the length of each subinterval. So pi, 2 pi, 3 pi, 4 pi. So those are my 4 subintervals. So I start at 0, then I go up, and instead of going 1, what's my amplitude? My amplitude is 2, so I go up 2. So there's my next point. Then I go back to 0. That's the easy one. And of course we end on 0, so you have 3 zeros in these. And then here, my amplitude is 2, so I go down 2. So I'm going to go down 2 here, so that makes it this. That's 2. 1, 2. And there we go. So remember, make sure you label your axes, otherwise, there's not going to be any way to tell. Because we're not using a uniform axis for all these problems. Like I said, that would be nice, but then some would be really, really big, and some would be really, really big, really tiny. Okay, so let's finish this up here. And there we go. And I could have made this smaller. I just tried to give you some kind of sense of size, so I made this pie pretty good size, okay? So something like that. Okay, let me move this up a little bit. So hopefully that makes sense. All right. Okay, hopefully that's good to go. Oops, let's focus this in here. Okay. So you can see, again, we figured out our period was 4 pi. So each subinterval was pi. All right. And then our amplitude was 2. So we're going to go up 2 and down 2 rather than up 1 and down 1. And this gave me the period, and I had a shift of 1. So I shifted up 1. Then I go up 2. So there's 0, up 2, 0, down 2, back to 0 off of this line. Okay? So that's number 57. Okay? Hope those all make sense, and hope that helps. Just take a look at this, think about the way we do this, and try these. Draw your scales and your graphs or your axes here, and hopefully that will all help. Good luck.